Assalamu alaikum warahmatullahi wabarakatuh. My name is Sadnan Sakir. I'm currently doing engineering in electrical electronics at University Technology Malaysia. I'm doing my internship and final year project under the supervision of Associate Professor Dr. Hanif bin Ibrahim. In this video, we are going to focus on SCAPS 1D software. The main objectives of these videos are we are going to concentrate on basic things of this software, and we will try to come along with a particular design of a solar cell based on a literature as a reference where we will try to figure out the solar cell performance parameters. Now, the instructions regarding the installation of this software, which is the SCAPS 1D software, has been readily available on internet. We can follow those instructions, and once it has been successfully installed, it will appear like this will be our introductory interface, and this has been named as the action panel. I hope that this video will help those beginners who are starting with the SCAPS 1D software and want to try to design their desired solar cell. So as we can see, there are so many options available here. So at the very first, we're not going to focus on those. We will try to focus on set problem option at the very first. Once we click down there, then this is the solar cell definition panel that will appear. This is actually going to develop the structure of the solar cells of ours. So if I move on to the add layer one, then these are the layer properties panel where we are supposed to input several parameters, which are the band gap, the electron affinity, dielectric permittivity, and so on regarding of that particular material. As I have aforementioned, we are going to refer a particular literature in order to support and create the solar cell. So I will try to come along and will try to give a brief explanation on that paper at the very first. This is the paper that we are going to follow, and this paper has been named as the simulation based investigation of inverter planar perovskite solar cell with all metal oxide inorganic transport layers. And in this particular paper, Muhammad Sadudur Rahman has been named as the first author. So this is the table at the very first we are going to focus mainly on, and this table will help us to design the solar cell. Due to time limitations, we have already designed this particular solar cell at the very first. So we will try to focus and learn based on that designed solar cells already. So now I will go through details with each and every particular layer that has been already provided. So this is the layer that we are trying to focus on. So at the very first, we are going to concentrate on the NiOx layer or the material, and these are the properties that are being provided here. So as we can see, the thickness has been given as 80 nanometers. So 80 nanometer has been inserted here, which is the 0.08 micrometer if we convert it in micrometer. Then the band gap, the electron affinity, which is the 3.1, 2.1, 10.7 consecutively has been provided, and we are just inputting all those values here. Now same goes for other materials as well. Like if we considering the perovskite one, then let's see how we can put down the values for the perovskite layer. It is like the 320 nanometer, which is the 0.32 micrometer. If you convert it in micrometer, then we are having the 1.56 for the band gap, and so on. All the parameters we are required to set at the very first. Same goes for the titanium oxide as well. Over here we are going to follow and put down all the necessary details here based on the titanium oxides, and we will try to set up all the values and input all the values there. So now we are going to talk about the defect layer density. In this respect, the informations regarding the defect layer density has also been provided in this paper if we go through. So in this paper, from this paper, we can get the defect properties like for the NiOx, MaPbI3, and TiO2 as well. We are concentrating on these three for this video. So for the NiOx, the defect density, we will just put down. I will just move on to this particular option, and we will just put down all the necessary details that are being given in this particular table, and we will try to achieve it, and we will click down the button accept. After that, all those values will appear automatically if we are being able to come along with the correct input regarding all these defect densities, the electron diffusions, and so on. So the same goes for other layers as well. The perovskite one, like there is the defect one, we will put down all the values that are provided in that paper. and along with the titanium oxide as well. So now what we will concentrate on, like we are not going to concentrate that much on this particular paper, maybe we will try to cover it on another video regarding the absorption coefficient, but there is an option that I'm going to show, like if we want to set down any particular um, absorption coefficient model in our solar cell. Those who are dealing with solar cell, they are quite frequent, and they actually know about the absorption properties of a particular material. So we can set down this value both manually, and if it has already been built, there are a few built-in absorption properties that are already been provided in SCAPS 1D, we can use that one as well. So those who are designing their solar cells using the SCAPS 1D software, they will definitely know about the absorption properties and their desired absorption properties. This one is sometimes important. So now today we are not going to concentrate on that particular part. So once it has been ready, then we will click down the OK button at the very first, and then we are going to concentrate on this particular part of the SCAPS 1D software. For us, the temperature for 300 Kelvin, which is the room temperature, it has been absolutely okay. We are not going to change that particular temperature at all, but we will try to observe this particular design when the solar cell, which is the light that is going to be appeared from front to the back. So now what we'll do, we will try to concentrate on that part, and we'll try to put down the light over here. So once it has been given, like so many options are has become readily available in this particular respect. So we will try to see the current and voltage graph, like the relationship between the currents and the voltage graph, and we will try to set down the voltage limitations until 2, and we will try to select this option as well, like we want the system to stop after the open circuit voltage. Once it has been ready, what we will try to do, we will try to put down this particular option, and we will click on this one, which is the calculate single shot. Once it has been clicked, now we are getting the results that we are trying to see. And over here, once it has completed its simulation, it has been written like simulation done, then what we can do, we will just try to see the current and voltage relationship graph. And this is the one that we are just trying to achieve, which is the solar cell performance parameters, which is the open circuit voltage, the short circuit current, the fill factor, along with the power conversion efficiency. So these particular properties of solar cell performance parameter may vary if we vary the thickness of the perovskite layer or even other particular layers as well. Let's say if we put down this value to 0.1, then the results that we are going to achieve, it will be different. Even the graphs that appeared here will be some extent different. As we can readily see that the percentage that have been achieved, it has been changed, and these are the differences that we have seen. This is the graph previously, this is the one previously that we have seen, and this is the one previously, whenever the thickness has been reduced to 0.1. So this is how we can make comparison. I would like to see some, like to show some of the work that I've tried to come along with. So this is actually the thickness of the perovskite layer. We have varied the thickness of the perovskite layer from 0.1 until 1.5 manually, and then this is the results that we are achieving, and based on that we can create some sort of graphs to make some sort of statement and comparisons as well. So this is how we can come along with the power conversion efficiency, the fill factor, the short circuit current, the open circuit voltage, along with the changes in the thickness of the perovskite layer. So today in this particular video, we have tried to cover pretty much this about all these about the SCAPS 1D software. Hopefully this video will help, and inshallah we'll try to come along with and moreover a particular manual has been available as well, where more or less the instructions has been provided regarding the beginning or the basic introductory about the SCAPS 1D software. So that is basically all from me. Thank you so much for listening. Assalamu alaikum wa rahmatullahi wa barakatuh.